Is the tricky transformations video number 2. Okay, so on this one, what they're asking us to do, I am assuming that you're very good at doing, like if I say that y is equal to a f of b times x minus c plus d. Okay, so if it's out front, it's going to be a vertical stretch. If it's inside, it's going to be a horizontal. It's going to affect it horizontally, which if it's a compression of b or a stretch of 1 over b, and then it's going to shift it to the right c and up d. So that is foundational, and I think that HL kids, you're really good at that already. And if I didn't say like function, if I actually gave you, if I said like y is equal to 2x minus 3 squared plus 7, I don't know, you could tell me the transformations very easily. However, now we're going to get a little bit more challenging. They've given us this graph, and I'm not overly concerned about what the equation is. I just want to know what it looks like. And they're saying, okay, let g of x equal the absolute value of f of x. Okay, so what this means is what comes out of f of x are the y values, but now any y value that I got that was negative needs to become positive. Okay, so when I look at this graph here, I'm cruising along. I think I end up here at positive, wherever this is. And it's doing something like this. But once it gets here, the y values go negative, but I need to make them turn and go positive. So I'm going to have this point, positive 1, it was negative 4, it's now going to be positive 1, positive 4. So it's going to turn and do that kind of a shape here. And then this is at, what is this, 1, 2, 3. 1, 2, 3 is where it's going to come back. And then I'm going to shoot, oh, my concavity is wrong, so sorry. Okay, something like that. So it's a parabola where the part that had been negative got folded up on top, if you can see that. The next one, they want us to take, it's the absolute value of x here. So if you think about this, we've got, on this original graph, I had the point negative 1, 0. I had the point positive 1, negative 4. And I had the point 3, what is that, 3, 0. And I had this guy right here and this guy right here look nice and pretty. So this was 2, negative 3, and this one was 0, negative 3. Okay, so those are some of the points that I know on that graph. And so h of x, if this is my x value, let's do negative 1, 0, 1, 2, 3. And then the absolute value of x, and then f of the absolute value of x. Okay, so if I take the absolute value of negative 1, I get 1, and now the value from 1 on this graph was negative 4. 0, the absolute value of that is still 0. You know what? I should grab something over here. So say, well, I didn't save enough room for my table. I want a negative 2. So if I look at, I'm going to make my table bigger. This is x, the absolute value of x, and then f of the absolute value of x. Oh, okay. If I have a negative 3 or a negative 2, that gives me a 3 or a 2. And then when I find, well, at 3, I had the point 0. And then at 2, I had the point negative 3. So now here at 0, where was I? I was at negative 3. At 1, I was at negative, that's still positive 1. Here's the negative 4. At 2, I'm at negative 3. And at 3, I was at 0. So here are some of the points that I need to graph. If I look at 0, it was negative 3. And then at positive 1, it's negative 4. But at negative 1, it's also negative 4. Can you see my, oh, I'm so sorry. And that's over here. And then at negative 3, let's do negative 2. Negative 1, 2. At negative 2, it was at negative 3. At positive 2, it's at negative 3. At 3, 1, 2, 3, it's 0. At negative 3, it's 0. Okay, so basically what happens, here's this graph. Basically what happened was we took the positive part of this graph here and reflected that part to now become quadrants 2 and 3. So do you see how this part right here was exactly what we had But then all of our negative x's here needed to do what their positive compadres were doing in quadrants 1 and 4. So that's how that one worked. The next one takes us asks us to do 1 over f of x. Okay, so if you remember, if I have 1 over, we're looking at, this is j. J is equal to 1 over f of x. One thing that we cannot do, because we are not Chuck Norris, is we cannot divide by 0. Okay, so anywhere that I have a y value of 0 from this original graph, I'm now going to have an asymptote. And so it was at -1 and +3. So at -1 and +1, 2, 3, I now have asymptotes because I can't plug in. If I try and say f of -1, f of -1 is 0. 1 divided by 0 is no good. Okay, and so then as we continue, we think about, well, 1 over something that's really, if I have 1 divided by something that's really big, 1 divided by something that's really big, this gets really small. Okay, if I have 1 divided by something that's really small, really small, it starts getting, or maybe I should do an arrow. It becomes, the bigger this gets, the smaller that gets. The smaller the denominator gets, the bigger the value becomes. And then same idea, if I made this a negative big number, it becomes a negative small number. Or a negative small number here becomes a negative big number there. That doesn't make a whole lot of sense. Let's look back up here. Okay, so when I think about, I'm approaching from the left, and I'm coming here, and my values, they started out pretty big, and then they're getting smaller and smaller and smaller. My y values are getting smaller and smaller and smaller. Well, that means that 1 divided by a really small number starts getting bigger and bigger and bigger. Okay, so what that's going to do is it's going to, let's see, we have, do we have a nice easy point to identify? Well, let's see, if we went over 1 and up 1, over 2, up 4, and then I could go over 3 and up 9. Okay, so there's a point at -2, down up here, this was -2, and then it was 9 up from -4, so that's 5. And so at -2, I'm now at 1/5. So I'm somewhere in here, and this is it's gonna get closer and closer to 0, and then it's gonna shoot up. Oh, I'm so sorry. I keep forgetting to move the paper. It's going to shoot up something like this and get closer and closer to infinity. The smaller the y value gets, the bigger its reciprocal becomes. So as it gets smaller, that's going to get bigger. Okay, and then in here, what happens? Well, at -1, I was at -4. So at -1 here, I'm now at, instead of, so wait, g of negative, oh, not g, j, so sorry, j of -1 is equal to 1 over f of -1. Well, f of -1 was -4. I lied, +1, my bad. Okay, this is equal to 1 over -4. And so at +1, I'm somewhere in here. And then as these values got closer, they got smaller and smaller in the negative direction, its reciprocal is going to get bigger and bigger. It's going to get bigger and bigger in the negative direction. And then same thing happens over here. Something like that. And then, because I'm approaching and I'm getting smaller and smaller and smaller, so its reciprocal is getting bigger and bigger and bigger, but it's a bigger and bigger negative number. When I come over here and I approach from the right and I'm cruising along this way, I start getting smaller and smaller, so I'm going to do something. I'm sorry, there we go. I'm going to do something like this over here. Okay, so that's the graph of the reciprocal of f of x. So I would encourage you to go try the other ones and then check my answer key. Good luck. I hope that was clear.